In this example, we're going to introduce another very common locus. So we want to represent the following on an argon diagram, and we haven't seen anything like this before. Argz equals 5 pi by 6. However, we do know what the argument of a complex number is. So what we want is the set of points such that z has an argument of 5 pi by 6. Now 5 pi by 6 on my diagram is shown by this ray here. So all of the points that I put there would represent complex numbers z that have an argument of 5 pi by 6. So all we need to do is draw a line going along that ray. But note that the line starts here at the origin. This is something that's known as a half line. So what have we got in part B? Our complex number z needs to have an argument that's between pi by 6 and pi by 2. So pi by 6 is here, pi by 2 is up here. But mod z also needs to be between 1 and 3. Well, we know that mod z equals 1 is a circle of radius 1, centre at the origin. And mod z equals 3 is a circle of radius 3, centred at the origin. So our z needs to be between the rays and between the two circles. In other words, it's going to be this part just here. And the final part of this example is arg z minus 1 is greater than negative pi by 6. Well, z minus 1. With the z's, our ray started at the origin. Arg z minus 1 is going to start at the point 1, 0. So in other words, it's going to be here. But the argument is negative pi by 6, which means it needs to be parallel, not to the ray I just drew, but the second one there. That's pi by 6. But that one's coming from the origin. We need to be parallel to that one, but going from the point 1. So it would be like that. Now we need the argument to be greater than that, but remember, arg finishes at pi. Our args always go between negative pi and pi. So what we're going to do is we're going to shade up here, but we're going to stop at the axis there because this would be where arg z minus 1 is equal to pi. So it would just be in that top part of the diagram.